Okay, so we're looking at a series of 5 problems. You're trying to select a problem that might be easy to do. Quickly looking through it. Number 1, they do give an image to it. A lot of words to it. Number 2 is a summation problem. Could be a little bit sticky. It's got trig functions in it. Number 3, a circle problem. Seems like there's some kind of a theme here. Number 1 was a circle. 4 looks like an equation to solve. Might be reasonable to do. And 5 looks like the easiest problem to do for me. All right, so let me attack 5 first. And it says the sum of 2 prime numbers is 85. So I know what the set of prime numbers looks like. It starts with 2, then it goes to 3, and then 5, yada, yada, yada. Well, what I know about it, whatever the 2 numbers are, they add up to an odd number. Now you should realize there's only one even number here. All the other primes are odd. And an odd plus an odd would have to be an even. And why is that the form of those things? 2k plus 1. You might put the other one down as 2n plus 1. And if you sum those two together, you definitely would get an even number. So it can't be 2 numbers from this set over here. It's got to be 2 plus some number from that set. So an even plus an odd. Again, an even might look like this. Let me write this down for you. An even might look like 2k. And then odd would look like 2n plus 1. And if you add those 2 numbers together, you would get an odd number. So I'm pretty convinced that number 2 is the first prime number. Let me get my eraser out. But I don't know the other one. But what I do know, I know the sum is 85. Whoops, sorry about that. I didn't mean to do that. The sum is 85. So the number I don't know, call it x, the prime number, equals 85. So what's the other number? X would be equal to 83. What's their question now? What is the product of these 2 prime numbers? Well, the 2 prime numbers are 2 and 83. And the product of those things, 2 times 83, is going to be 166. Let's see if I got it right. Number 5, right? 166. Again, it's all typed up. All right, let me go back. Problem set. Go backwards. That was a confidence builder. Let me erase this stuff over here. And the next one I'd go to is number 4. And looking at it, it looks kind of nasty, actually. Now, certainly there's many things I could do. I could do the domain of the problem, all that kind of stuff. But I'm gonna try to focus in on making the problem a little bit easier to look at. And what I'm going to do is I'm going to say, I notice that the root, x minus 3, is in both of the problems. Whoops, sorry about this. Before I go forward, I want to tell you that u is a positive number. I know that much. And I know x has to be greater than or equal to 3 right now. What I'm going to do is I'm going to square both sides, and you would get u squared is equal to x minus 3. And I would say u squared plus 3 is equal to x. All right? So I'm going to go and substitute that in. And again, this could make it worse, might make it better, who knows. Let me write this over here. And let's see what I get. So what would I get? X plus 1. Well, x plus 1 would be u squared plus 3 plus 1, which would be u squared plus 4. Minus 4 times the root of x minus 3, which is going to be 4u. Let's do the next one, x plus 6. Well, that would be u squared plus 3 plus 6 would be u squared plus 9. Minus 6u. Well, I'm starting to realize that these things are perfect squares. So let's write this down. It's the root of u minus 2 quantity squared plus the root of u minus 3 squared equals 1. Well, this is where things get a little bit tricky. I'm going to use the absolute value symbol. I want to point out a lot of people make the mistake in saying that, oh, the square root of x squared is x. That's not true. It's the absolute value of x, and that's a common error. Let's write this down. So what do I get here? I get u minus 2, but the absolute value of it, plus the absolute value of u minus 3 is equal to 1. All right, so what do I got here? I got possibilities here. And I want to point out what the possibilities are. And this is always trouble for me. I got to look at these absolute values. And I'm going to say it kind of breaks up into, when u is less than 2, that's one case. When the u is between 2 and 3, that's another case. Another case would be where u is greater than 3. All right? Let's talk about the case where u is less than 2. Okay, where u is less than 2. Well, if u is less than 2, right, both of these things over here, let me just highlight this for you, would be negative numbers. So when I take the absolute value of that, what would I get? I would get 2 minus u plus 3 minus u is equal to 1. And what does this give me? This gives me minus 2u plus 5 is equal to 1. Minus 2u would be equal to minus 4, and u would be equal to 2. But you know what? That's not making sense in there, is it? And why is that? It says that u has to be less than 2. So this one's making no sense. And cross it out now. I'm done with that. All right. Let me go for when the u is greater than 3. When the u is greater than 3, what do I get? I would get, they're both going to be positive now. U minus 2, and I'm doing this one over here now, plus u minus 3 is equal to 1, and 2u plus 5 would equal to 1, right? 2u would be minus 4, and u would be equal to minus 2. Well, that's not greater than 3, so this one makes no sense, all right? So I'm going to keep doing this, and I'm going to try this one now, and this is probably the trickiest one to do. And what does it say? It says, the u is between 2 and 3. So what would I get now? I'm doing this one now. I would get, the absolute value of u minus 2, if u is between 2 and 3, would be equal to u minus 2 plus, well, if it's between 2 and 3, it's going to be the opposite of u minus 3, which would be 3 minus u. All right, and that's supposed to equal to 1. Well, let's take a look at that. What do you get over here? You would get no u's, but you would get 1 equals 1. It's an identity. So it's true for all u here. All right? Now, someone can say that's the answer to the question. That's not the answer to the question. The answer to the question is, what's x? And that's where I got to go back and put this down now. So what's u? U is the root of x minus 3. And what's that between? It's between 3 and it's between 2. This is relatively simple to solve. I'm going to write this down over here. Make sure I make a mistake here. I got to add 3 to all sides, right? 7, x, and 12. I'm going to commit to this answer over here. By the way, certainly x is greater than or equal to 3. That's a solution to the problem. All x between 7 and 12. All right, let's go to our k. And I want to point out in the k, I think this is number 4, right? Yeah, number 4. It's a bit of work. I want to point out, I did the problem slightly different over here. I want to point out there's variation in the way people do problems. One day I do a substitution, another day I don't do a substitution, but it doesn't matter what you're doing. The answer is going to be the x can be between 7 and 12. I also provide a picture over here for you that may or may not be helpful to students looking at that. So I'm pretty convinced that, whatever work I was doing on that particular day was that work. Other days, different level of work. So I'm going to go back and I'm going to start to erase the board again. And let me erase. That wasn't so bad, but I did need to know about absolute values and substitutions. It's a tedious algebra problem now. All right, let me go back. All right. I'm going to attempt to do number 2 now. You may wonder why I'm saving these other guys for last. The circle problem is always problematic for me. So let me put on what I've done. I've done 5. I've done 4. I'm now going to attempt to do 2. And the way I'm going to do this, and it's an addition problem, right? It's a series with a bunch of terms in it. And these ... means over here is the pattern is pretty obvious what the ... is. I'm going to write this down in terms of degree mode, though. All right? And someone says, why do you do that? Well, some of the reasons is a little bit easier for me to look at degrees, believe it or not. It's my first language. All right, so I want to convert that to a degree measure so I can start to see a pattern in the problem. And it's really not a bad problem. And I'm going to say pi over 6, well, that's 30 degrees, right? I'm going to write this over here for you, 30 degrees. The next one would be, twice that, which would be 60 degrees. And then it's going to be, it keeps going up by 30 degrees, right? So the next one would be 90 degrees. The next one would be, what would that be? That would be 120 degrees. And what's the next one going to be? I got to be careful, 150 degrees. I'm going to do it until I get one cycle done. 180 degrees. And then 210 degrees. And then what did you get? 240 degrees. Again, I'm going to just do one cycle. Once I hit the 360, I know it keeps repeating itself. And then 270, 300, 330. I'm really jamming that in, aren't I? 360. Wow, that was a lot of work. So now what I'm going to do is I'm going to talk about how to evaluate these guys over here. I think you probably should know that these are pretty easy to evaluate. So I'm going to write the sequence down for that. Root 3 over 2. Then you get 1/2. 0. And now I'm moving into the second quadrant. The reference there would be 60. So that's going to be minus 1/2. And then minus root 3 over 2. And then 0. And then I'm moving into the third quadrant. And it's still going to be negative there. And 240 would be 60 degrees. And that would be 1/2 now. And then minus 1/2. And minus root 3 over 2. 0. Then I'm moving into the fourth quadrant now. You notice these are appearing in groups of 3 at this point. All right? I'm just feeling around for it. By the way, I'm nowhere near this guy. Nowhere near. All right, nowhere near. So let's take a look at that. What's the last one going to be? Well, cosine. So it's going to be, let's see. It would be, I'm at 300 degrees now, so 60-degree reference. So that'll be 1/2. And then root 3 over 2, and then 0. And I'm back at 360. Let's see. I can't even read my own writing. 270, 300, 330, 360. And that would be 1, right? All right, see, I'm seeing groups over here, though, aren't I? Oh, you know what? I forgot to put the 180 down. Sorry about that. The 180 is minus 1. I just forgot all about that guy. I just forgot about him. And let me go through that again. So 30, 60, 90. 120, 150, 180. I'm sorry about that. You know what? I got to erase this. It's just jamming that in there too much. I'm going to go back over that again. And let me write these down again for you. 30. Whoops. 60, 90. I'm just adding 30 on each time. I'll be more careful. I'll try to be a little bit neater too. Let's see, 120, 150. I got to do it down here now. 180, 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees, and 360 degrees. And I got one cycle completed out now. And again, I'll write the numbers down again. And again, I apologize for probably misspeaking there and not really thinking. But what are you going to get? You're going to get root 3 over 2, 1/2, 0. 120 would be a reference of 60, so minus 1/2, minus root 3 over 2. Just trying to get one cycle down. 180 is actually going to be, for the cosine curve, minus 1. 210 has a reference of 30, and that's going to be minus root 3 over 2 now. Let me make sure I'm doing that. Well, 180, 210 is 30, and that would be minus root 3 over 2. And then minus 1/2. 270 would be 0. 300 would be a reference of 60. A reference of 60 would be 1/2. And then root 3 over 2. And then 360 would be 1. All right, let me get my red pen out. I think I'm a little more careful over there. And I'm starting to see that things are starting to collapse here. So I know that when I get through one cycle, the sum would be 0. The sum would equal 0 for one cycle. But here comes the problem now. What I mean by the problem of this thing is that I got to start moving forward. And the question becomes is how many cycles are there? And, I'm looking at that number 2014. Let me write this down over here. 2014 pi over 6 times, I'm going to convert it to degree measure, 180 degrees over pi, right? So what's this going to be? Well, it's kind of tough to do, but I guess I could do that. The pi's cancel off. 6 goes to 180, 30 degree times. So it's 2014 times 30 degrees. All right? Then the question is, 360 degrees goes into that, right? And there would certainly be a remainder. And I realize that's tough, but let me write this down over here. So 2014, 30 degrees. And how many times does 360 degrees fit into that? And certainly degrees will cancel off. I'm going to write this down for you. And I'm going to put down 2014. I'm just kind of reducing it. And 30 into 360 is 120, right? I'm just trying to find the integer number that goes in that. Then I'll talk about what the remainder is. What do you get there? I'm wondering how many times 360 go into that? Well, it's going to be 1007 over 60. All right, I got to do division now. And this is my problem. 60 into 1007. Let me see if I did that. I'm sorry. I made a mistake there. It goes in 12 times. I'm making a lot of mistakes today. Okay, let me do that. Let's see, 1. You get 6. 40, 6. That's 36. 47. Right, so let's see. 7 times 6 is 42, right? And that would give me, let's write this down now. So it goes 167 times. That means I get 167 of these cycles. And I get a remainder, right? I get a remainder of what? And a remainder of 5 over 6. So there's 5/6 of 300 degrees left over. And what would that give me? Well, let's see. I'm sorry, 360. I'm sorry. I'm thinking forward. And that would give me 300 degrees. That's what's left over. So what I have to do is, I'm saying that this is what's left over. And let's count it up. All right? And I'm sorry I wasn't a bit neater in this thing over here, but I gotta circle these things, and the two on the end are missing. So I'm doing these over here. Let me get a different color now. So this, and this, this, and this. Let's see what else I'm left off with here. Well, these cancel off, right? So what am I left off with? Let's write this down. It looks like I'm left with -1. I'm seeing that here. Everything else is canceled off. Minus √3 over 2. Let me just simplify that. That would be 2 minus √3. I'm going to write this as -2 plus √3 over 2. Now, certainly mistakes happen. You know, in the beginning, I got a little bit sloppy, and then I corrected myself. I forgot a number, and that can happen. All right, so let's just take a look. And I'm going to go back over here and see if I got it. And what number is this? Number 2, right? Yep, right there. Okay. All right, that was a tough one. A lot of bookkeeping there. Let me start to erase. And now I'm going to attack those problems I really didn't want to attack. And I want to do number 1. And it says, in a square with sides of length 1. So what I'm going to do here is I'm going to put an axis in. And I'm going to call this the x-axis. Give me 1 second to do so. The x and the y-axis here. Okay, the x-axis, y-axis. So it says in a square with sides length 1. So I know this is 1 here. And I know this is a 1 here. By the way, this is the origin, 0, 0. Okay, so it says in a square with sides length 1 and a quarter circle is drawn. I see the quarter circle. That's, I'll put that in red. I'm seeing that quarter circle there. That's a quarter of a circle, right? Quarter circle is drawn with center at the top left corner. I'm seeing that. There's center there. And let's keep looking at it. By the way, the radius of this circle over here is 1. All right, radius is 1 of that circle. I can put the equation of that circle down. I'm not sure if that's necessary at this point. That's the top center, half circle is drawn with the right side of the square as its diameter. I'm seeing that. So I'm seeing that the right side of the circle, and this guy's radius is a half. I'll call this my first circle, my second circle, 1/2. All right, I'm seeing that. I see the accompanying figure. I see that. Figure 68, page 263. Kind of glad they drew that out for me. Yep, 263. Let me make this blue. And this is R2, and that's a half. All right, let's keep going. And a smaller circle that's tangent to the quarter circle and the half circle. I see that too. I'm seeing it over here. I'm seeing this guy over here. Now, I'm going to look at their question. The smaller circle is drawn tangent to the quarter circle, half circle, the bottom edge. Oh, determine its radius. I have no idea. So what I want to do is I want to put a center in here. And I'm going to say it appears the radius is some number y. All right, so I'm going to say the radius is some number y. You could also say it's some number x too if you want. But now what I'm going to look at a line like this. I'm going to look at a line like this. All right, I'm going to put this point here. This point here is going to be, well, the x is going to be 1, and the y will be 1/2 there. This point here is 0 for the x and 1 for the y, right? The length of this line over here, again, the radius of the small circle, this is the radius of small circle, is y, right? So what's the length of that? Well, if you thought about it, it's the length of this line over here, right? The length of this line over here is going to be the radius, I'll just call this distance 1, is going to be the radius of the big circle 1 plus the radius of the small circle, which is y. A lot going on here, isn't there? Let's do this one over here now. I'm going to call this distance 2. What's distance 2? It's the radius of the that quarter circle, which is 1/2, plus the y. All right? And I haven't discussed this point yet. And what is that point? Well, there's going to be some number x here, right? Let me write that down for you. That's going to be x, comma, y, with the understanding that's where the center of that circle is. So let's see if we get a relationship down. And let me just carefully look at this. A lot of stuff has been drawn down at this point. And this is some reason I don't like it because I'm not very good at drawing or even looking at what I've put down. But I guess I could do, I gotta be careful here, don't I? So I'm looking at it. Wish I had more space to write on. And let's take a look over here. Well, let's start writing things down. And I want to do the distance between this point and that point. And that's going to be 1 plus y. I'm going to do distance squared, though. Equals, let's put this down. That's going to be the change in y's. And I'm looking at this point and this point, which is going to be 1 minus y squared plus, I'm doing distance squared, by the way, get rid of the root symbol, 0 minus x squared. All right, I'm going to highlight this, indicating it may be useful to me. And I'm going to put the other guy down, the other relationship. And let's see if we can write that one down now. So that's going to be, I'll be careful here. And again, I'm looking at the distance 2. It's going to be 1/2 plus y. I'm going to do distance squared again. Equals, well, let's see, 1/2 minus y squared plus 1 minus x squared. I'm going to highlight that one too. By the way, my big concern is to find out what the y is in the problem, because once I get the y, I got the problem done. And I got to go through this, right? I'm going to do one thing at a time. I'm going to do this one first, and I get 1 plus 2y plus y squared equals 1 minus 2y plus y squared plus x squared. Well, I think I see some things over here, and I'll just point out that I could subtract 1 from both sides. I could subtract y squared from both sides. And I get a, pretty simple relationship over here. I get 4y is equal to x squared, but I still don't know what the y is. Let me look at the second equation, this one over here. I'll see if I can do that. A little more difficult though, right? So 1/4 plus y plus y squared equals 1/4 minus y plus y squared is equal to, it's going to be a little more difficult, right? I'm sorry, I didn't mean to do that. I'm just squaring the other thing out, right? Plus 1 minus 2x plus x squared. Well, let me get my pen out again, and my red pen, and cross things off that they're going to subtract from each side. This goes. Let's see, what would I get? Let me write this down for you. Looks like I'm getting 2y. I got these guys over here. Would be 1 minus 2x plus x squared. And let's see if I did that okay. I got 2y, 1 minus 2x plus x squared. Yeah, I think I'm doing okay. And why is that? Well, I got to multiply this thing by 2, and I get 4y equals 2 minus 4x plus 2x squared. And now I'm going to look at this, and I know what 4y is. It's just x squared. So I get x squared equals 2 minus 4x plus 2x squared. I'm starting to realize I can get x. And if I can get x, I can get y. So it's going to be 0, x squared, let's see, minus 4x plus 2. Well, I got to do this now. X equals, you know what I'm going to do? I'm going to complete the square. Looks easier than using quadratic formula. This would be minus 2, x squared minus 4x. Half of minus 4 is minus 2 squared. You get plus 4. I'll add 4 to both sides. So it's going to be 2 equals x minus 2 squared. So x minus 2 would be plus or minus the root of 2. Don't panic yet. X will equal 2 plus or minus root 2. By the way, there's no way x could be 2 plus root 2. And the reason for that is if you went back to your picture, it would be over here then, and that's just out of the question. So x, the only possibility for x now is 2 minus root 2. All right? So I'm going to go back over here, and I think I can figure out y now. And let's write this down. So 4y is equal to 2 minus root 2 squared. And y is the radius of the circle. That's what we're going to do, right? So you get 4y, this is 4, plus 2 minus 4 root 2. And let me just take a look at this, if I did this right. 2 squared is 4, root 2 squared is 2, minus 2 root 2 minus root 2 is minus 4. So it's going to be 4y equals 6 minus 4 root 2. I'm going to divide both sides by 4, and you get 6 minus 4 root 2 over 4. I'm going to reduce that. That's 3 minus 2 root 2 over 2. I'm going to claim that's the radius. So I think I'm done. And let me just see how I did with that. And again, that was a lot of work though, wasn't it? And that's number 1. And number 1, I'm saying it's 3 minus 2 root 2 over 2. Yeah, right over here. Okay? So it's 3 minus 3 root 2 over 2. We did okay. Let me just make sure I said that right. Yeah, Yeah, the same answer. All right, so we're plowing along. I know it's taking longer than usual, and I want to do another one. The last one to do is this 3 circles of equal size are inscribed in a bigger circle of radius 1, so that every circle is tangent to each other. This is what's known as a kissing circle problem. What is the radius of each of the smaller circles? And I'm gonna do my best attempt drawing the kissing circle problem for you. I'm gonna find some space over here. Let me see where it is. Let me see where the answer is first of all. I did that one, and I think I need space somewhere. I'll do it here. So the kissing circle problem, it looks like this over here. And again, I realize when I'm drawing things, I'm not very good at drawing here. But these are 3 circles that are inside a big circle like this over here, and they're kissing. Everyone's kissing, all right? I'm going to put down the centers, all right? Boy, it looks like a cartoon character. And again, I want to read the question again to you. 3 circles of equal size are inscribed inside a bigger circle of radius 1. I know the big circle is radius 1, by the way, so that every circle is tangent to each other circle. What is the radius of the small circles? Well, I have no idea. So what I'm going to do is I'm going to draw an equilateral triangle in. And I want to point if I did that, this is what the equilateral triangle is going to look like. Where the sides of the equilateral triangle are going to be 2r, that's the radius of the small circle, 2r, that's the radius of the small circle, 2r, all right? And all these angles are going to be equal angular at 60 degrees, 60 degrees, 60 degrees. I'm just trying to remind myself of it. And then I got a center over here, right? And I'm going to put a line over here and a line over here going through this over here. So let me kind of draw a bigger picture. And I'll put this over here. And I've got something like this over here. And I've got a line going through this like this. All right? And a line going through like this over here. And then I'm going to put a line. Let's see what I got over here. Something like this now. And I'm going to put a right triangle there. And I'm going to say this now is R. I'm kind of looking at this now, and I know some of the angles, right? And again, my wish is to get the R. Now take a look at that, right? I'm going to maybe blow this up a little bit. That's not going to help me, is it? I gotta be careful about this. Well, I know this angle here, that would be 60 degrees, right? I know this length here too. I know this entire length here is 1. I think I can figure this out. And I'm going to put that down now. So let me not blow it up, but shrink it down a little bit. So I want to get this length here. Let me see if I can put that down for you. So I'm going to say the sine of 30 degrees, that's that angle over there. Now I'm going to do cosine. The cosine of 30 degrees would equal R. That's the adjacent to that over X. And what's the cosine of 30 degrees? That would be root 3. Let me make sure I'm doing this right. That would be, this would be a 1. This is root 3, 2. Root 3 over 2, right? Is equal r over x. And so x would equal 2r over root 3. I think I know what x is now, right? So I think I can figure out r. So if x is equal to that, and this entire length is 1, this is r. I'm looking at my picture now, I see it now. So r plus x is equal to 1. What's x? It's 2r over root 3 is equal to 1. I'm going to pull the r out. And what do you get? 1 plus 2 over root 3 is equal to 1. I'm going to simplify this a tiny little bit. R root 3 plus 2 equals 1. I got to keep going with this, by the way. R is going to be equal to root 3 plus 2. I can multiply top and bottom by root 3 minus 2. And r would equal 3 minus 2 root 3. And the bottom would be 3 minus 4, right? That's minus 1. So this will be 2 root 3 minus 3. All right? Let's see how we did. I made a mistake somewhere, didn't I? Oh, I'm sorry. I'm not even looking at the answer. It's right over here. I was looking at the wrong answer, by the way. Yeah. All right, not bad. I took a long path there, and my pictures weren't so good. Got a little confused at times. And that happens when you're on an exam, right? So I say we did everything. All right. I hope I didn't do, too many crazy things on this one over here. So I wonder, I write the right stuff down sometimes, and I get distracted. All right. But anyway, it's tough. Let me go back and review what I found to be the easiest problem to do. I found 5 to be easy. All right. With the substitution, I found 4 to be manageable. All right. This one over here, kind of tedious to do, but we did get through it. The big numbers are really what throws me, to get the period down. How many times does it fit into the period? That really bogs me down. The circle problems are always causing a little problem for me, but we got through those guys over there. Again, sometimes I'm going to say if you need to reach out to me, please do so. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. And when I say reach out to me, I do mean that. Like if I'm not being overwhelmed with people, asking questions and having, comments, I can get back to you. And I don't think it's going to be terribly busy postings, but, if they are, I may not be able to get back to you. I do want to remind you, though, that these, the material that you're seeing over here, and it's, there's 300 some odd pages. It's really designed for the prison mathematics project participants only. But at some point when things get vetted and I feel comfortable with this thing, I'll be publishing it out. And it's just simply over years I've collected some problems. And not every problem I've collected, but I've collected some interesting problems. I kind of just threw them together and came up with a document that, basically I hate to say keep people busy, but I think working problems does keep people busy and takes their mind off things. I think working problems is an important way to pass time, by the way. It's like solving puzzles. And more importantly, it takes your mind off things. And that's one of the main reasons a lot of people do mathematics. It takes their mind off things. So again, I'm hoping to take your mind off something for a while. and improving your ability to solve problems, all right? What kind of problems? Mathematic problems. Again, it may have a relationship to your career goals, may not. Bottom line, it may just be entertaining, like doing a crossword puzzle. It does sharpen the mind, though, and I do believe that. It's like mental exercise, and I believe people should not only do physical exercises, but mental exercises. Thank you for paying attention.